Today's episode is wild. We're talking about a subject that's been a staple of science fiction for decades. Custom lab-grown human organs. And the future is a lot closer than many of you might think. I'm Ben. This is Physics or Bust. Every year, thousands of people die waiting for an organ transplant. And even when a donor organ becomes available, there's a high risk of rejection because the body sees that new organ as a foreign invader. But imagine a world where you could walk into a hospital, and instead of waiting for a donor, the doctors can make a brand new organ just for you, from your own cells. That world got a whole lot closer thanks to researchers at Cincinnati Children's Hospital. They've engineered multi-zonal liver organoids, which are tiny lab-grown livers which recreate the liver's natural zoning, detoxification zones, metabolism zones, and bioproduction zones. Each of which is absolutely necessary for a truly functioning liver because all the zones have to work together like a tiny biological factory. And the real kicker? When these tiny livers were transplanted into rats with failing livers, the survival rate almost doubled. That's not just progress, that's a quantum leap. Especially considering that there are over 9,000 Americans sitting on a waiting list waiting for someone else's liver. And every year an estimated 2,000 people on that list die without ever getting a replacement. Not to mention the countless number of people that don't even become eligible to be on the list. And that's why we need a better method of obtaining replacement organs rather than waiting for one person to die so that we can take the good organs they still have. Another great development is out of UC San Francisco and Cedars-Sinai. Researchers have developed synthetic organizer cells, basically giving stem cells a GPS coordinate and a to-do list. Grow into a heart, form a ventricle, start beating. It's the biological equivalent of building a house, but the blueprint builds itself. If we perfect this technology, the possibilities are insane. Need a kidney? Grow one. Tailor-made from your own DNA. Mass-produce arteries and blood vessels for emergency surgeries. Pre-grow livers or kidneys or pancreas tissues for patients that have chronic diseases that affect those organs. Bioengineer patches of cardiac tissue to replace damaged tissue because of heart attacks. Why do a full transplant if you don't need to? And beyond healthcare, my mind constantly goes to space exploration. If you're on Mars and something goes wrong, you can't exactly hop on back to Earth for a transplant. But what if you could grow what you need, when you need, where you need, even off-world? Especially as we get closer and closer to sending ships to Mars, this technology is definitely something worth developing. But, and this is a big but, there are still major hurdles between today's successes and tomorrow's custom organ factories. First major challenge? Vascularization. Real organs are packed with thousands, even millions, of tiny blood vessels. Without them, lab-grown tissues can't deliver nutrients deep into the tissue. That's a death sentence for complex structures like a real kidney, liver, or pancreas. The second challenge is called innervation. Innovation? That's what they're doing! No. Innervation, not innovation. Organs like the heart and gut require a connection to the nervous system. Growing a blob of cells that contracts in a rhythm is one thing. Growing a heart, or any organ, that syncs with your body's signals is a whole new level that unfortunately has been overlooked in most organ and tissue engineering applications, except ones dealing with the brain itself. This is partially due to the intense complexity of innervation when growing an organ. As researchers from one group and another group each make their own advances, hopefully we'll be able to combine all these advances in the future so that we can have real functioning lab-grown organs. Our third challenge is scalability. Right now we can grow tiny organoids, but scaling them up to full human-sized organs with full functionality is extremely tricky. And don't forget, we still have regulatory hurdles, ethical dilemmas, and the massive cost that would be incurred for each organ. While in the future this might become the standard treatment for someone that has a problem with an organ, it definitely won't start out that way. Like most new medical tech, initially the high cost will be too high for most people. But in the future, as the process gets refined and the cost starts coming down, we will start seeing this in mainstream hospitals. But every one of these challenges needs to be tackled before you can stroll into a hospital and order a new liver. But here's the thing, just 10 years ago, growing functional human organ tissue seemed like science fantasy. I certainly believe that if things go right, we could see the first lab-grown organ transplant within the next 15 years. We're witnessing the birth of an entirely new frontier in medicine. So let me ask you, if you could pick an organ to replace or upgrade, which one would it be? Put your thoughts in the comments below. If you enjoyed this video, I think you'd like this book. I have an affiliate link in the description below. I do get a small commission, but it doesn't cost you any extra. And for more space and science news and updates, make sure to like and subscribe, and remember, keep asking questions. I'll see you in the next video.